Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us more to share our video. Subscribe if you have not subscribed before. By this time, you should subscribe on the channel. It's very important. And also, any video you watch, please kindly leave a comment below. Just you see a comment bar and comment on it for for modification and also of direct updates. Just in case you want to reach us, you can make use of this line. Now, with this line, you can call us, you can WhatsApp us, and also Telegram is allowed. Either of the three, you are good to go. Okay, on this video, I'll be working on closure. Now, we all know in our reanalysis time, when something is closed, it means that particular set is a member of that is a member of that given set. A number is closed. Okay, when 2 is an element of real number, then it is closed. Which is close also means closure. We also talk about closure and closure. Now, this time around, you need to understand principle behind closure, which is to be on the video list, on topology list. Don't forget, this is topology, which is advanced mathematics. Now, the outline of this video, I'm working on definition and example. By the end of this video, you will understand this outline. Now, let me start from definition. Now, let me try to define something. Define what's called closure. Now, okay, when we talk about closure, definition says that. Now, look at the definition. Let A be a subset of a topological space X and Y. Then the set A union B, A union A prime, consisting of A and all its limit points is called the closure of A, and is denoted by what? By this. Now, note, A closure is the intersection of all closed sets containing in A. That is what I mean by that. Please, whenever you have a set like this, A, B, you are looking for what? Closure. That is what you are looking for. Take note of that very well. It's not hard. It can be B, C, D, wherever. Anytime you have something like this, A, this is closure. Now, can you see it's different from just like a vector? When you come back to normal vector of mathematics, just take note of that. Now, with what I've explained here, let me try to give example. Now, let A be a subset of a what? Topology. I think I've explained what is called topology, which is open. Now, then the set A union A prime and is denoted by, consisting of A and all its sets, all the limit points is called the closure of A, and is denoted by what? That is that. Now, note, all is the intersection of closed sets containing in what? A. Now, with what I've been explaining, let me try to give example that will illustrate my definition. It's good to understand from example so I will be able to write your own English without no stress. Now, look at this example. Now, look at the example. Let S be A, B, C, D, E, and the tau, which is the subset A of power set, anyhow you call it, A empty set, singleton of A, SD, AB, ACD, BCDE. Now find closure of A. This is closure of A, closure of AC, and closure of BD. Now, how do I go on this thing? Let's try to work it out. Solution. Because of my space, I will really manage this board. Don't forget, my X is given. This is my X, and this is my what? The tau. Very, very important. Those two things are very, very important at this point. Now, since I have those two things, I will now continue. The first thing I will do is that now I will not say that from the definition, just come from the definition. From the definition, the closure of a particular set will find all the closed sets containing the set and then select the smallest. You select the what? The smallest, the least. Don't forget the smallest or the least smallest element. Now, you have to select the smallest element. That is very, very important. Don't forget, let me repeat mine. To find the closure on that particular of a particular set, we find all the closed sets. That is very important. Containing the set and then select the what? The smallest of them. Now, by now, you should know how to find the what is it called? Closed and closed set and open set. Now, this can be open, which is all these are open, and this can be what? Closed. Now, and I've explained to you, this is my open set, empty, singleton of A, C, D, A, C, D, B, C, D, E. These are my open set. Now, to get my closed set, the first thing I will do, x minus x, it will give me empty. This one, x minus empty, it will give me x, and x minus singleton of A, it will give me B, C, D, E. B, C, D, E. Now, I'll move on to x minus CD. It will be x minus CD. X minus CD, it will be A, B, E. A, B, E. Now, yes. A, B, yes, that is that. Now, I'll move on to the next one. X minus A, C, D. X minus A, C, D, which it will be equals to B, E. B, E. The last part, X minus A, C, D, E. It will be equals to only A, which is singleton set. Now, can you see? I will not come out and say that my closed set, these are my closed set. Let me list out closed set. Closed sets are empty, X himself, B, C, D, E, and A, B, E, B, E, and singleton of what? Of the given set A. Now, since I have that, I will now continue. The next thing I will do now, number one, plus permit me to draw. Please, we need your sponsorship at this point. We need to buy a bigger board so that we won't be managing board anymore. Now, for me to find my what? B closure. Now, how do I go for my B closure? I will to find B closure containing. Okay, to find B closure, find all closed sets. You find all closed sets containing B and select the smallest. Find all closed sets containing B and select the smallest. That's what I was telling you that time. Smallest. Now you need to select the smallest of all that contains what in B. Now what I said that contains B in B, which is close. I have X himself. I have B, C, D, E, and I have, what else do I have? I have A, B, E, and I have B, C, E. These are the sets that contain in what? In that term. Now, BE. Now, what else I might need to do? I will now look for the smallest of them. This can never be smaller. This is the cardinality of this is 5. The cardinality of this is what? Is 4. Cardinality of this is 3. Now, the least of them is this. This is the least, which is cardinality of what? Of 2. Now, this is the least. I will now continue by having now ends B prime equals to what? BE. That is my B prime. I mean B closure. That is my B closure. The least is very important. Please, the least or smallest number of in cardinality. Please take it of that. I think I've explained what is called cardinality before. Now, if I need to continue now, I think I've listed my closure here. These are my closure sets. Please, I need to rub the upper part of it so that you'll be able to see what I'm doing. I'll show you how to generate the closure. Now, the last part of this, okay, the second question, which says that we are looking for AB closure. AB closure. Now, I will now look for all the sets that contains AB. All the sets that contain AB. Now, what are the sets that contain AB? I will look for them from the closed set. Now, I think X is there. We have X, comma. We have what else that contain AB? This does not contain AB. We have A, B, E. We have A, B here. Now, what else that contain AB? That is all. These are the two sets that contain AB. Now, since I have those two sets, I will now look for the least. Cardinality of this is 5. Cardinality of this is what? Is 3. Now, among them, which one is the smallest? 3 is the smallest. I will now do that what? Closure of AB equals to what? B, C, E. A, B, E. A, B, E. That is the closure of that. A, B, E. Now, A, B, A, B, E. Okay. Oh, no. This is not in this. Sorry. I cannot use this. Because I have to use X only. If the answer is X only, because this is not allowed. Sorry for that silly mistake. I'm so sorry. Now, the set that contains I'm talking about BC, not the question. I've changed the question, sorry. AC, close. Sorry for that mistake. AC from the from the closure, which is AC. What I said that contain AC, AC only. AC from the, that's AC, OC is only X, sorry. X only. X only. It's only my head that contains AC. Sorry, I've changed the question that time in my mind, which I made mistake of. Now, it means there's no counterpart, no, you don't need to compare with any of them. Now, it means ends AC closure equals to X. That's my answer. That is my answer. Now, it means AC closure is X. AC closure equals to X. Now, the last part of it, which I need to work on, is BD. Is my BD. My BD, I'll be having BD closure. Look at the closed set. Look at the closed set. The one that have BD, I will be talking about X, comma, and B, C, D, E. B, C, D, E. What else I have there? B, E, and A, which is they are not what you are looking for. These are the two things that contain BD on the given set. Now, I will now look for the cardinality, which is cardinality of this particular one is 5. Cardinality of this, which is going to be 1, 2, 3, 4 is 4. Now, since it's 4, I will now pick for 4. Hence, BD equals to what? ACDE. That is my answer. That is all what I need to find on the closure. It means the first one, this is my first one, the second one, and the third one will be BD close will be equals to what? ACDE. That is what I mean. It means the answer to number 1, to number 2, not to number 3. Can you see? It's very, very simple to find a closure of a given set. Don't forget you are home with Further Solutions Academy. On my next video, I will be working on metric space. You know, it's a very, very nice part of metric space. It's a very nice part. Metric space. That is what I will be working on. We have been talking about topology, but this time around I will start working on its particular distance of a given set. Now, don't forget you are home with Further Solutions Academy. Once again, thanks for watching.